Section 9 of the Chemistry of Cookery. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Adrian Stevens. The Chemistry of Cookery by W. Mattieu Williams. Cheese, Part 1. I now come to a very important constituent of animal food, although it is not contained in beef, mutton, pork, poultry, game, fish, or any other organized animal substance, unless in egg yolk, as Layman states. It is not even proved satisfactorily to exist in the blood, although it is somehow obtained from the blood by special glands at certain periods. I refer to casein, the substantial basis of cheese, which, as everybody knows, is the consolidated curd of milk. It is evident at once that casein must exist in two forms, the soluble and insoluble, so far as the common solvent water is concerned. It exists in the soluble form and completely dissolved in milk and insoluble in cheese. When precipitated in its insoluble or coagulated form, as the curd of new milk, it carries with it the fatty matter or cream, and therefore, in order to study its properties in a state of purity, we must obtain it otherwise. This may be done by allowing the fat globules of the milk to float to the surface, and then removing them by separating the cream as by the ordinary dairy method. We thus obtain in the skimmed milk a solution of casein, but there still remains some of the fat. This may be removed by evaporating the solution down to solidity, and then dissolving out the fat by means of ether, which leaves the soluble casein behind. The adhering ether being evaporated, we have a fairly pure specimen of casein in its original or soluble form. This, when dry, is an amber-coloured translucent substance, devoid of odour and insipid. The insipidity and absence of odour of the pure and separated casein are noteworthy, as showing that the condition in which it exists in milk is very different from that of the casein of cheese. My object in pointing this out is to show that in the course of the manufacture of cheese new properties are developed. Skim milk, a solution of casein, is tasteless and inodorous, while fresh cheese, whether made from skimmed or whole milk, has a very decided flavour and odour. If we now add some of our dry casein to water, it dissolves, forming a yellowish viscid fluid, which, on evaporation, becomes covered with a slight film of insoluble casein, which may be readily drawn off. Some of my readers will recognize in this description the resemblance of a now well-known domestic preparation of soluble casein, condensed milk, where it is mixed with much cream, and in the ordinary preparation also much sugar. The cream dilutes the yellowness, but does not quite mask it, and the viscidity is shown by the strings which follow the spoon when a spoonful is lifted. If a concentrated solution of pure casein is exposed to the air, it rapidly putrefies, and passes through a series of changes that I must not tarry to describe, beyond stating that ammonia is given off, and some crystalline substances, such as leucine, tyrosine, etc., very interesting to the physiological chemist, but not important in the kitchen, are formed. A solution of casein in water is not coagulated by boiling. It may be repeatedly evaporated to dryness and redissolved. Upon this depends the practicability of preserving milk by evaporating it down or condensing. This condensed milk, however, loses a little. Its albumen is sacrificed, as everybody will understand who has dipped a spoon in freshly boiled milk and observed the skin which the spoon removes from the surface. This is coagulated albumen. If alcohol is added to a concentrated solution of casein in water, a pseudo-coagulation occurs. The casein is precipitated as a white substance, like coagulated albumen, but if only a little alcohol is used, the solid may be redissolved in water. If, however, it is thus treated with strong alcohol, the casein becomes difficult of solution or even quite insoluble. Alcohol added to soluble casein renders it opaque and gives it the appearance of coagulated albumen. The alcohol itself dissolves a little of this. The characteristic coagulation of casein, or its conversion from the soluble to the insoluble form, is produced rather mysteriously by rennet. Acids generally precipitate it either from aqueous solution or from milk. The coagulation effected by mineral acids from aqueous solution is not so complete as that produced by lactic acid from milk or vinegar, the former coagulum being more readily redissolved by alkalis or weaker basic substances than the latter. A calf has 4 stomachs, the fourth being that which corresponds to ours, both in structure and functions. It is lined with a membrane, from which is secreted the gastric juice and other fluids concerned in effecting the conversion of food into chyme. A weak infusion made from a small piece of this mucous membrane will coagulate the casein of 3,000 times its own quantity of milk, or the coagulation may be effected by placing a small piece of the stomach, usually salted and dried for the purpose, in the milk and warming it for a few hours. Many theoretical attempts have been made to explain this action of the rennet. Simon and Liebig suppose that it acts primarily as a ferment, converting the sugar of lactic into lactic acid, and that this lactic acid coagulates the casein. This theory has been controverted by Selmy and others, but the balance of evidence is decidedly in its favour. The coagulation which occurs in the living stomach when milk is taken as food appears to be due to the lactic acid of the gastric juice. Casein, when thoroughly coagulated by rennet, then purified and dried, is a hard and yellowish horn-like substance. It softens and swells in water, but does not dissolve therein, nor in alcohol, nor weak acids. Strong mineral acids decompose it. Alkalis dissolve it readily, and if concentrated, decompose it on the application of heat. When moderately heated, it softens and may be drawn into threads and becomes elastic. At a higher temperature it fuses, swells up, carbonizes, and develops nearly the same products of distillation as the other protein compounds. Note the differences between this and the soluble casein above described, that is, that obtained by simply removing the fat from the milk, then evaporating away the water, but using no rennet. I have good and sufficient reasons for thus specifying the properties of this constituent of food. I regard it as the most important of all that I have to describe in connection with my subject, the science of cookery. It contains, as I shall presently show, more nutritious material than any other food that is ordinarily obtainable, and its cookery is singularly neglected, is practically an unknown art, especially in this country. We commonly eat it raw, although in its raw state it is peculiarly indigestible, and in the only cooked form familiarly known amongst us here, that of a Welsh rabbit or rarebit, it is too often rendered still more indigestible, though this need not be the case. Here, in this densely populated country, where we import so much of our food, cheese demands our most profound attention. The difficulties and cost of importing all kinds of meat, fish, and poultry are great, while cheese may be cheaply and deliberately brought to us from any part of the world where cows or goats can be fed, and it can be stored more readily and kept longer than other kinds of animal food. All that is required to render it, next to bread, the staple food of the Britons, is scientific cookery. If I shall be able, in what is to follow, to impart to my fellow countrymen, and more especially countrywomen, my own convictions concerning the cookability and consequent improved digestibility of cheese, I shall have done the state some service. Taking muscular fibre without bone, that is, selected best part of the meat, beef contains on average 72.5% of water, mutton 73.5%, veal 74.5%, pork 69.75%, fowl 73.75%, while Cheshire cheese contains only 30 1/3, and other cheeses about the same. Thus, at starting, we have in every pound of cheese rather more than twice as much solid food as in a pound of the best meat, or comparing with the average of the whole carcass, including bone, tendons, etc., the cheese has an advantage of 3 to 1. The following results of Mulder's analysis of casein, when compared with those by the same chemist of albumen, gelatin, and fibrin, show that there is but little difference in the ultimate chemical composition of these, so far as the constituents there named are concerned. In casein, carbon 53.83, hydrogen 7.15, nitrogen 15.65, oxygen and sulfur 23.37%. Comparing albumen, gelatin and fibrin, carbon, albumen 53.5, gelatin 50.40, fibrin 52.7, hydrogen, albumen 7, gelatin 6.64, fibrin 6.9, nitrogen, albumen 15.5, gelatin 18.34, fibrin 15.4, oxygen, albumen 22.0, gelatin 24.62, fibrin 23.5, sulfur, albumen 1.6, gelatin the same, fibrin 1.2, phosphorus, albumen 0.4, gelatin the same, fibrin 0.3. We may therefore conclude that, regarding these from the point of view of nitrogenous or flesh-forming and carbonaceous or heat-giving constituents, these chief materials of flesh and of cheese are about equal. The same is the case as regards the fat. The quantity in the carcass of oxen, calves, sheep, lambs, and pigs varies, according to Dr. Edward Smith, from 16% to 31.3% in moderately fatted animals, while in whole milk cheeses it varies from 21.68% to 32.31%, coming down in skim milk cheeses as low as 6.3. Dr. Smith includes Neuchâtel cheese containing 18.74% among the whole milk cheeses. He does not seem to be aware that the cheese made up between straws and sold under that name is a ricotta, or crude curd of skim milk cheese. Its just value is about 3p per pound. In Italy, where it forms the basis of some delicious cheeses, such as budino di ricotta, it is sold for about 2p per pound or less. There is a discrepancy in the published analysis of casein which demands explanation here, as it is of great practical importance. They generally correspond to the above of Mulder within small fractions, as shown below in those of Shearer and Dumas. Carbon, Shearer 54.665, Dumas 53.7. Hydrogen, Shearer 7.465, Dumas 7.2. Nitrogen, Shearer 15.724, Dumas 16.6. Oxygen and sulfur, Shearer 22.146, Dumas 22.5, both columns totaling 100. In these the 100 parts are made up without any phosphate of lime, while, according to Laymen, in his Physiological Chemistry, Volume 1, page 379, Cavendish edition, casein that has not been treated with acids contains about 6% of phosphate of lime, more consequently than is contained in any of the protein compounds we have hitherto considered. From this it appears that we may have casein with and casein without this necessary constituent of food. In precipitating casein for laboratory analysis, acids are commonly used, and thus the phosphate of lime is dissolved out. But I am unable at present to tell my readers the precise extent to which this actually occurs in practical cheese-making, where rennet is used. What I have at present learned only indicates generally that this constituent of cheese is very variable, and I hereby suggest to those chemists who are professionally concerned in the analysis of food that they may supply a valuable contribution to our knowledge of this subject by simply determining the phosphate of lime contained in the ash of different kinds of cheese. I would do this myself, having during some 10 years past nearly forsaken the laboratory for the writing table. I have not the leisure for such work, and worse still, have not that prime essential to practical research, especially of endowed research, a staff of obedient assistants to do the drudgery. The comparison specially demanded is between cheeses made with rennet and those Dutch and factory cheeses, the curd of which has been precipitated by hydrochloric acid. Theoretical considerations point to the conclusion that in the latter much or even all of the phosphate of lime may be left in solution in the whey, and thus the food value of the cheese seriously lowered. We must, however, suspend judgment in the meantime. In comparing the nutritive value of cheese with that of flesh, the retention of this phosphate of lime corresponds with the retention of some of the juices of the meat, among which are the phosphates of the flesh. These phosphates of lime are the bone-making material of food, and have something to do in building up the brain and nervous matter, though not to the extent that is supposed by those who imagine that there is a special connection between phosphorus and the brain, or phosphorescence and spirituality. Bone contains about 11% of phosphorus, brain less than 1%. The value of food in reference to its phosphate of lime is not merely a matter of percentage, as this salt may exist in a state of solution, as in milk, or as a solid very difficult of assimilation, as in bones. That retained in cheese is probably in an intermediate condition, not actually in solution, but so finely divided as to be readily dissolved by the acid of the gastric juice. I may mention, in reference to this, that when a child or other young animal takes its natural food in the form of milk, the milk is converted into unpressed cheese or curd prior to its digestion. Supposing that, on an average, cheese contains only 1/2 of the 6% of phosphate of lime found, as above, in the casein, and taking into consideration the water contained in flesh, the bone, etc., we may conclude generally that 1 pound of average cheese contains as much nutriment as 3 pounds of the average material of the carcass of an ox or sheep, as prepared for sale by the butcher, or, otherwise stated, a cheese of 20 pounds weight contains as much food as a sheep weighing 60 pounds as it hangs in the butcher's shop. Now comes the practical question: can we assimilate or convert into our own substance the cheese food as easily as we may the flesh food? I reply that we certainly cannot if the cheese is eaten raw, but have no doubt that we may if it be suitably cooked. Hence the paramount importance of this part of my subject. A Swiss or Scandinavian mountaineer can and does digest and assimilate raw cheese as a staple article of food, and proves its nutritive value by the result, but feebler bipeds of the plains and towns cannot do the like. I may here mention that I have recently made some experiments on the dissolving of cheese by adding sufficient alkali, carbonate of potash, to neutralize the acid it contains, in order to convert the casein into its original soluble form as it existed in the milk, and have partially succeeded both with water and milk as solvents. But before reporting these results in detail, I will describe some of the practically established methods of cooking cheese that are so curiously unknown or little known in this country. In the fatherland of my grandfather, Louis Gabriel Mattieu, one of the commonest dishes of the peasant who tills his own freehold and grows his own food is a fondue. This is a mixture of cheese and eggs, the cheese grated and beaten into the egg as in making omelettes, with a small addition of new milk or butter. It is placed in a little pan like a flower pot saucer, cooked gently, served as it comes off the fire, and eaten from the vessel in which it is cooked. I have made many a hearty dinner on one of these, plus a lump of black bread and a small bottle of genuine but thin wine, the cost of the whole banquet at a little auberge being usually less than sixpence. The cheese is in a pasty condition and partly dissolved in the milk or butter. I have tested the sustaining power of such a meal by doing some very stiff mountain climbing and long fasting after it. It is rather too good, over-nutritious, for a man only doing sedentary work. A diluted and delicate modification of this may be made by taking slices of bread or bread and butter, soaking them in a batter made of eggs and milk without flour, then placing the slices of soaked bread in a pie dish, covering each with a thick coating of grated cheese, and thus building up a stratified deposit to fill the dish. The surplus batter may be poured over the top, or, if time is allowed for saturation, the trouble of preliminary soaking may be saved by simply pouring all the batter thus. This, when gently baked, supplies a delicious and highly nutritious dish. We call it cheese pudding at home, but my own experience convinces me that we make a mistake in using it to supplement the joint. It is far too nutritious for this. Its savoury character tempts one to eat it so freely that it would be far wiser to use it as the Swiss peasant uses his fondue, that is, as the substantial dish of a wholesome dinner. I have tested its digestibility by eating it heartily for supper. No nightmare has followed. If I sup on a corresponding quantity of raw cheese, my sleep is miserably eventful. A correspondent writes as follows from the Charlotte Square Young Ladies' Institution. I have been trying the various ways of cooking cheese mentioned in your articles in Knowledge, and have one or two improvements to suggest in the making of cheese pudding. I find the result is much better when the bread is grated like the cheese and thoroughly mixed with it. Then the batter is poured over both. I think you will also find it better when baked in a shallow tin, such as is used for a Yorkshire pudding. This gives more of the brown surface, which is the best of it. Another improvement is to put some of the crumbled bread on paper in the oven till brown, and eat with it as for game. I have not succeeded in making any improvement in the fondue, which is delightful. My recollections of the fondue of the Swiss peasant being so eminently satisfactory on all points, nutritive or sustaining value, appetizing flavour, and economy, I have sought for a recipe in several cookery books, and find at last a near approach to it in an old edition of Mrs. Rundell's Domestic Cookery. A similar dish is described in that useful book, Crefid's Family Fare, under the name of cheese soufflé or fondue. I had looked for it in more pretentious works, especially in the most pretentious and most disappointing one I have yet been tempted to purchase, that is, the 27th edition of Francatelli's Modern Cook, a work which I cannot recommend to anybody who has less than 20,000 lire a year and a corresponding luxury of liver. Amidst all the culinary monstrosities of these high-class manuals, I fail to find anything concerning the cookery of cheese that is worth the attention of my readers. Francatelli has, under the name of eggs à la Suisse, a sort of fondue, but decidedly inferior to the common fondue of the humble Swiss osteria. As Francatelli lays the eggs upon slices of cheese, and prescribes especially that the yolks shall not be broken, omits the milk, but substitutes, for high-class extravagance's sake, I suppose, a gill of double cream to be poured over the top. Thus the cheese is not intermingled with the egg, lest it should spoil the appearance of the unbroken yolks. Its casein is made leathery instead of being dissolved, and the substitution of 6 pennyworth of double cream for a half-pennyworth of milk supplies the high-class victim with 5 pence halfpenny worth of biliary derangement. In Goufflé's Royal Cookery Book, the household edition of which contains a great deal that is really useful to an English housewife, I find a better recipe under the name of cheese soufflés. He says, put 2 ounces and a quarter of flour in a stewpan with 1.5 pints of milk, season with salt and pepper, stew over the fire till boiling, and should there be any lumps, strain the soufflé paste through a tammy-cloth. Add 7 ounces of grated Parmesan cheese and 7 yolks of eggs. Whip the whites till they are firm and add them to the mixture. Fill some paper cases with it and bake in the oven for 15 minutes. Crayfith says, grate 6 ounces of rich cheese, Parmesan is the best, put it into an enamelled saucepan with a teaspoon of flour of mustard, a saltspoon of white pepper, a grain of cayenne, the 1/6 part of a nutmeg grated, 2 ounces of butter, 2 tablespoons of baked flour, and a gill of new milk. Stir it over a slow fire till it becomes like smooth, thick cream, but it must not boil. Add the well-beaten yolks of 6 eggs, beat for 10 minutes, then add the whites of the eggs, beaten to a stiff froth. Put the mixture into a tin or a cardboard mould and bake in a quick oven for 20 minutes. Serve immediately. Here is a true cookery of cheese by solution, and the result is an excellent dish, but there is some unnecessary complication and kitchen pedantry involved. The soufflé part of the business is a mere puffing up of the mixture for the purpose of displaying the cleverness of the cook, being quite useless to the consumer as it subsides before it can be eaten. It further involves practical mischief, as it cannot be obtained without toasting the surface of the cheese into an airtight leathery skin that is abnormally indigestible. The following is my own simplified recipe. Take 1/4 pound of grated cheese, add it to a gill of milk, in which is dissolved as much powdered bicarbonate of potash as will stand upon a 3d piece, mustard, pepper, etc., as prescribed by Crayfith. Heat this carefully until the cheese is completely dissolved. Then beat up 3 eggs, yolks and whites together, and add them to this solution of cheese, stirring the whole. Now take a shallow metal or earthenware dish or tray that will bear heating, put a little butter on this, and heat the butter till it frizzles. Then pour the mixture into the tray and bake or fry it until it is nearly solidified. A cheaper dish may be made by increasing the proportion of cheese, say 6 to 8 ounces to 3 eggs, or only 1 egg to 1/4 pound of cheese for a hard-working man with a powerful digestion. Mr. E. D. Girdlestone writes as follows, I quote with permission. As regards the cheese fondue, your recipe for which has enabled me to turn cheese into a practical account as food, you may be glad to hear that it has become a common dish in our microscopic ménage. Indeed, cheese, which formerly was poison to me, is now alike pleasant and digestible, but some of your readers may like to know that the addition of breadcrumbs is, in my judgment at least, a great improvement, giving greater lightness to the compost, and removing the harshness of flavour otherwise incidental to a mixture which comprises so large a proportion of cheese. We, my wife and I, think this is a great improvement. I have received 2 other letters making, quite independently, the same suggestion concerning the breadcrumbs. I have tried the addition, and agree with Mr. Girdlestone that it is a great improvement as food for such as ourselves who are brain workers, and for all others whose occupations are at all sedentary. The undiluted fondue is too nutritious for us, though suitable for the mountaineer. The chief difficulty in preparing this dish conveniently is that of obtaining suitable vessels for the final frying or baking, as each portion should be poured into and fried or baked in a separate dish, so that each may, as in Switzerland, have his own fondue complete, and eat it from the dish as it comes from the fire. As demand creates supply, our ironmongers, etc., will soon learn to meet this demand if it arises. I have written to Messrs. Griffiths and Browett of Birmingham, large manufacturers of what is technically called hollowware, that is, vessels of all kinds knocked up from a single piece of metal without any soldering, and they have made suitable fondue dishes according to my specification, and supply them to the shopkeepers. The bicarbonate of potash is an original novelty that will possibly alarm some of my non-chemical readers. I advocate its use for 2 reasons. First, it effects a better solution of the casein by neutralizing the free lactic acid that inevitably exists in milk supplied to towns, and any free acid that may remain in the cheese. At a farmhouse, where the milk is just drawn from the cow, it is unnecessary for this purpose, as such new milk is in itself slightly alkaline. My second reason is physiological and of greater weight. Salts of potash are necessary constituents of human food. They exist in all kinds of wholesome vegetables and fruits, and in the juices of fresh meat, but they are wanting in cheese, having, on account of their great solubility, been left behind in the way. End of section 9.